Today's notes are brought to you by Bridges, and our title is Parallelograms Proofs Day 1. You're going to want to set up kind of a short area at the top for your definition, and the two major parts will both be titled Observation of a Parallelogram 1 and Observations of a Parallelogram 2. So what is a parallelogram? So the main definition of a parallelogram is that it's a four-sided figure, so 1, 2, 3, 4-sided figure, where the opposite sides are parallel. So I want to go ahead and write that definition down. A parallelogram is a quadrilateral that means it has four sides where the opposite sides are parallel. Now what we're going to do in this activity today and tomorrow is we're going to really take a look at the parallelogram and figure out if this is the only definition that they give us, what are some features or observations we can say about a parallelogram, just knowing that the opposite sides are parallel. So let's start off by looking at the parallelogram and see if we can, just by playing around with the diagram itself, see if we can come up with something. Now the first thing I know from the definition of a parallelogram is that it has four sides and that opposite sides are parallel. But the truth is, I don't really know a lot about quadrilaterals. I mean, I know that the angles inside a quadrilateral add up to 360, but I don't really know a lot about this shape. So the first thing I want to do is I'm going to change my perspective and I'm going to look at it as two triangles. Now, in order to do that, I'm going to connect A to C, and when I do that, I have a triangle up here, ABC, and a triangle down here, ADC. You see those two triangles? Now once I do that, then I can make some evaluations about these two triangles, because I know a lot about triangles, and I know a lot about parallel lines that are cut by a transversal. So let's make some observations. I know, I'm going to go ahead and call this angle 1 and angle 2. What kind of angles are those, angle 1 and 2? They're on opposite sides of this transversal. That's right, they're congruent. They're alternate interior angles. So I know that angle 1 is congruent to angle 2. And I know this because angle 1 and angle 2 are alternate interior angles. And alternate interior angles are congruent. Okay, if that's true, aren't these angles congruent too? Angle 3, here's angle 3 right here, and here's angle 4. Aren't those alternate interior angles for AB and CD? Yeah, they are. Okay, so I can say angle 4 is congruent to angle 3 because the same reason, alternate interior angles are congruent. Okay, so let's mark this on our diagram. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Now, my last thing I'm looking at here, because remember we're looking at this under the perspective of triangles. I know how to show triangles are congruent, and I'll let you in on a hint. I think this triangle is congruent to this triangle. Now, so far I've shown that this triangle up here and this triangle down here, they have two angles that are congruent to each other. So I'm looking at a formula or postulate, a theorem, that shows that triangles are congruent using two angles. Do you know which one I'm thinking of? That's right, angle, side, angle. So far I've got the angle and the other angle, but I'm missing the side. There needs to be a side that's included in between the angles. That side has to be AC. Now, here's what I know. AC is definitely congruent to itself. So I'm going to go ahead and write AC is congruent to AC. And the reason for that is because of the reflexive property. And let's mark that. That means right now that I've just shown that this triangle up here and this triangle down here are congruent. And they're congruent by angle, side, angle. That's angle, side, angle. That means that triangle ABC is congruent to triangle. Okay, I got to be careful here. ABC goes from the double angle to the single angle and then goes across the side they have in common. So for my second triangle, I'll have to start at the double angle. So I'll go from C to the single angle. So CDA and then across here. So CDA. And those two triangles are congruent because of angle, side, angle. Okay, so let's kind of backtrack. We started by looking at a parallelogram, and we want to make some observations about a parallelogram, but we decided to figure that out by looking at two different triangles. What we found out is that two congruent triangles make up one parallelogram. Now, if you remember, if two triangles are congruent, then that means all their corresponding parts are congruent also. So I'm going to change colors here. I'm going to go to green. Okay, that means that this side is the same as which side? Yeah, this side over here. And that's because corresponding parts of congruent triangles are congruent, right? And that also means that this side, BC, is also congruent to AD. Now, why is it important to make that observation? Well, remember, we're trying to make observations about the parallelogram. So what can I say about a parallelogram? Well, how would you describe this side and this side? What's their relationship? Well, I know they're congruent. Are they adjacent sides or opposite sides? I'd say they're opposite sides. So here's what I would write. My first observation of a parallelogram is that opposite sides are congruent in a parallelogram. Parallelogram. I hope I spelled that right. I'll center that off so it looks beautiful. So my first key idea that I've noticed is that in a parallelogram, I could say that the opposite sides are congruent. So now we've come up with some key ideas about a parallelogram. From the definition, we knew that a parallelogram has 1, 2, 3, 4 sides, and that opposite sides are parallel. Now, because of the observations we made first, we know that opposite sides are also congruent. So BC is the same measurement as AD, and AB is the same measurement as CD. Now we're going to make another set of observations, but this time, instead of looking at it as two triangles, I want to change my perspective, and this time I'm only going to look at them as two sets of parallel lines that happen to be intersecting. So I'm going to look at these parallel lines and these parallel lines, and just think about what I know about parallel lines. So I want you to imagine that these parallel lines are cut by two transversals, and these parallel lines are cut by two transversals. Okay? Okay, let's make a list of things we know. Now I'm kind of rigging this a little bit so that we're coming up with an observation that I like. So you're probably thinking, oh, maybe alternate interior angles are congruent, or maybe you're thinking corresponding angles are congruent. But I really want to look at this angle right here and this angle right here. So we'll call that angle A and angle B. What kind of angles are angle A and angle B? Remember, these are the parallel lines cut by this transversal. Are those angles on alternate sides or the same side? They're on the same side, so these two angles must be same side interior. And same side interior angles are supplementary. So I know that angle A plus angle B equals 180 degrees. And I know that because same side interior angles are supplementary. Okay, remember we're shifting gears. I also know if we look at this angle and this angle right here, so angle B and angle C, that we can make a conclusion there. Now this time we're looking at this line parallel to this line and this line being the transversal. If that's the case, these two angles are also on the same side. Doesn't it make them supplementary also? Okay, then that must mean that angle B plus angle C equals 180 degrees. Because, well, I'm not going to write it again, I'll just point to it. Because same side interior angles are supplementary. Now let's take a look and recap at what we've written. A plus B is 180, and B plus C equals 180. This makes me kind of think of the transitive property, but this isn't quite the transitive property. You could say that A plus B is 180, and B plus C is 180. That means that A and C are supplementary with the same angle. Let's think about what this would mean in numbers. So I want you to put a little example kind of up here. Let's guess, okay, we're just going to make a quick guess. If angle A is 100 degrees, okay, then angle B must be how much? Yeah, 80 degrees, right? Okay, well then that would mean angle C would be how much? Keeping this in mind, you know that B plus C also equals 180. Angle C would have to be 100, right? So this is a theorem that you actually learned a while ago. It says that if two angles are supplements to the same angle, then they're congruent. So here's what I'm concluding. Let me go ahead and grab my green marker. I can conclude that angle A and angle C are congruent. So let's go ahead and write that. Angle A is congruent to angle C. And I know that because, I'm going to write this up here, because they are supplements to the same angle. And that kind of came from our example right here. So A is congruent to C, and you know what? If we did the same experiment, we could have switched it, and we could have rigged it so that we could show that B plus A is 180, and A plus D is 180. They both are supplements with A, so B and D are, yep, you guessed it, also congruent. So this angle is also congruent to this one. So angle B is congruent to angle D. So what can I conclude? That opposite angles are congruent in parallelograms. Parallelograms. So I want you to go back to your original definition. We wrote that a quadrilateral where the opposite sides are parallel, that's the only definition we have of a parallelogram. But now, because of our observations, we can say a parallelogram is a quadrilateral where the opposite sides are parallel. And because of that, whenever I see a parallelogram, I can say two things. I can say the opposite sides are congruent, and I can also now say that the opposite angles are congruent. And that was just by doing some evaluating, given that the opposite sides were parallel. We just came up with that from our observations. So in your diagram, I want you to go ahead and draw that this side is congruent to this side is congruent to that side, and I also want you to show that the opposite angles are congruent by marking up your diagram like this. And then we know that the opposite sides and opposite angles are congruent.